Welcome to Satat Gyanarjanam. I hope you all are fine, and today finally we are going to start our class 11 physics second chapter, that is motion in a plane. So now till now we have completed our motion in a straight line chapter, and one more thing, that motion in a plane as well as motion in a straight line, this is the chapters of kinematics. What is kinematics? Kinematics, I hope you can remember. If you can't remember, let me know you all that what is kinematics. Kinematic is a branch of physics in which we used to study about study the nature of physics without studying the reason of physics. What I am saying, that we are going to study the nature of physics, nature of motion, but without understanding, here you can say, but without discussing the cause of motion. ठीक है, अब हम cause of motion को we are not going to study. हम cause of motion को नहीं पढ़ेंगे, but nature of motion को पढ़ेंगे. So kinematics is that branch of physics which used to focus on the nature of motion only. Then the motion in a straight line and the motion in a plane are both the chapter of kinematics. So the part 1 is motion in a straight line, the part 2 is the motion in a plane. देखो, now we are going to study that what is meant by motion in a plane and what is the difference between the motion in a straight line and motion in a plane. Then we are going to talk about the two-dimensional motion, which is same, that is motion in a plane, and we are also going to take a little bit introduction of 3D also. 3D means three-dimensional. Let's start. First of all, let's understand what is meant by motion in a straight line. Motion in a straight line. What is meant by motion in a straight line? In which whether you are traveling horizontally, vertically, or you can say in the instant, in only you can say one axis. Okay? One axis, or you can say one dimensional, it will be more, you can say it will be more important, you can say it is more efficient. ये ज़्यादा सही है, और it can describe the motion in a straight line in more better way. ठीक है, so if you want you can learn, otherwise इसको छोड़ दीजिए. What you have to do? You have to learn what is first dimensional motion, and we have already discussed a full chapter on the one dimensional motion, that is motion in a straight line. इसमें क्या होता है? इसमें कोई एक एक्सिस पे, for example, जैसे कि हमने पढ़ा already, we have talked about the x-axis, y-axis and z-axis. Z-axis can be either in outward or inward direction. So this is y, this is x, and this is z. For example, if you want to take if you want to see this real life coordinates in your real life, if you want to see this three-dimensional coordination, so you can see simply on the corners of balls. Here, where you can see that two opposite side walls are coming and they are joining. So when they are joining, they are making like this dimension, x-axis, y-axis and z-axis. Then we are not talking about the three-axis in three-dimensional motion, but we are talking about the two-dimensional. हम ऐसे पढ़ने वाले हैं motion in a plane. Motion in a plane consists of only two-dimensional, that is x-axis and y-axis. So one question I have that you must have to answer, that is because it is very important, not important, but it shows whether you have studied the chapter number 1 or not. You have studied the one-dimensional motion effectively or not, or you are already prepared with this chapter or not. First of all, let me know if I am saying that give me the real life examples of one-dimensional motion. Can you give me any one-dimensional motion? If yes, write in comment section yes with the reason. After some time, I am going to answer this question with the time is done. Then, now this motion is known as two-dimensional motion. two-dimensional motion where there is x-axis and y-axis. This is three-dimensional motion in which there is x-axis, y-axis as well as z-axis. So three-dimensional, two-dimensional and one-dimensional. One-dimensional is also known as motion in a straight line. A two-dimensional means you can say motion in plane, and here you can say motion in three-dimensional. Okay. You have to give example of one-dimensional now, and let me know you what is the, you can say simply, what is the example of motion in a plane that you can see in your daily life. Okay, daily life where I can say that I am going to give you a real life incident. For example, if I am saying कि if this is a ball, okay, not ball, it is football, and if a person is there and he has kicked this ball, so after some time it will go like this, and after some time it will go again to the ground. So what you have to assume, this is a ground level. तो मतलब उसने मारा and it goes to air, मतलब it travels in air for some time and then again it comes to the ground. ठीक है? Here you can see there is the ball is not in air, not in totally on ground. If I will say that this ball is totally in air, will it be true? No. If I will say that no, the ball is totally on the ground, is it true? No. But if I will say that the ball was in the air and the ground, you can say they are mix of air and ground, means when you are kicking it, it is going in air and it is traveling for some time in the air, but after some time it again comes to the ground. So can we say that this is a mixture of air and ground? Okay. So first of all I am going to answer this question कि आप इसके examples बताओ. Then we are going to discuss this example in more detail, because if you will understand this example, because this is the best example of motion in a plane. From this example also we are going to study the motion in a plane concepts. So first of all let's come to our next topic to understand the one-dimensional examples and does it exist or not. Let's come to our next topic. Okay, so let's talk what is the example of one-dimensional motion. So first of all, I have asked a question that whether this exists, and if your answer is yes, then give me the example. First of all, if I will say, what will be your reaction when I will say that there is no any real life example of the one-dimensional motion, and if it is very rare, means very rare. I will make you understand one more thing. Okay? You all know that is what is meant by one dimension. One dimension means if we can see that if there is a road and if a car is traveling in this direction, so what is meant by motion in a straight line means there is only a straight line. It is in x-axis or in y-axis. मीन्स इट मतलब मैं ये नहीं कह रही कि वाई एक्सिस में नहीं हो, वाई इन दोनों का मिक्सचर है. इट विल बी नॉट द मिक्सचर, इट विल बी ईदर इन वाई एक्सिस ईदर इन एक्स एक्सिस, not in, it will be not the mixture, because it will, if it will be get mixed, it will become motion in a plane. So is this possible कि we have road and we are traveling in one direction, it means we are doing one dimensional motion, या motion in a straight line? No, simply no. Why? Because we know that our earth is, our earth is not like this, but our earth is spherical shape, yeah, you can say geode shape. And because earth is circular shape, it is, even the earth is not in the x-axis or in y-axis, but Earth is in the mixture of x-axis and y-axis. Here you can say it is also the mixture of x-axis, y-axis, z-axis, and that's why in our real life mostly all our things are our things which are present inside present inside our home, you can say inside your office, yeah, everything around us, it will be in 3D. But you can also find the 2D things also. For example, if I will take this copy, if I will take this copy, and what you have to do, you have to assume that this is a car. Okay, so if I'm taking this surface, if I'm taking this you can say a very smooth surface, and if I am, मैं क्या करूँ? If for example, what you have to assume? You have to assume that this is a car, this marker is a car, and it is traveling along this surface, this is smooth surface. ठीक है? So what it will be? It will be motion in a plane. क्यों? Because we have horizontal axis, we have vertical axis also. So we are doing a mixture. We are in mixture of x-axis and y-axis. ठीक है? We are not in motion as straight line. But let me make you understand where is 3D here. So for 3D, as I this will be x-axis, y-axis, and z-axis. Y-axis, x-axis, and z-axis. I'm writing in very rough way, but I hope you can. This is origin, this is x-axis, this is y-axis, and this is z-axis. Z-axis, one more thing, that z-axis can be present inwards or outwards of the different axes, that is x and y. So what I am saying here, let me make you understand that what is 3D now. For example, we all know that this copy is a combination of x-axis and y-axis. What you have to assume now, you have to assume that this marker is now a housefly. Yeah, you can say a mosquito. So can you see? Can you observe? Can you remember that the mosquito or the housefly, they can also walk on the ground. Okay? They are also traveling on this surface, this smooth surface. They can walk on this surface. They can sit on this surface. But they can also fly. In this, you can say in this dimension. And because there is a combination of x-axis, y-axis, and now z-axis, this will be 3D. I hope till now you have understood the x-axis, one-dimensional, two-dimensional, and three-dimensional example. So this was all for your starting, you can say, information. And as in my you can say motion and straight line, I haven't make you understand what is exactly one-dimensional motions, two-dimensional motions, and last three-dimensional motions. One more thing, if some will say that is there any 4D or 50 or fourth dimension, if fifth dimension also, is there any other dimensions other than this 3 dimensions? No, till now we haven't you can say we haven't discovered any other type of dimensionals till now. But as if you are interested in the astronomy or astronomical things, you have heard from somewhere that what will be dimensions there? What will be their dimensions? We can't understand the dimensions. As such, there are some statements like that, and I hope you all have heard about it. If you are already interested in the astronomy and you are interested in understanding the facts of astronomy, so you have heard about these statements, and these statements actually shows that scientists are also, you can say, there is some dimensions, that is fourth or fifth, that we are unable to understand till now, and that's why till now we haven't recognized them very exactly. This was all about your introduction. Let's start our motion in a straight line, motion in a plane with that example. So first of all, let's come to the next topic to start our main topic, that is motion in a plane. Okay, so let's start our motion in a plane. So first of all, what you have to do, you have to just focus on this example. this is a point. Let's assume that this line shows the ground. And this is a football here. And a person is here. And as I have told you that he is kicking this football. So when he kicked it with some angles, देखो क्या होता है? If I have a ball, and if you are not kicking it, because while kicking, if you are just making it roll, if you just want to make any ball roll, for example आपके पास कोई ball है and ठीक है, and you what you have to do, आपको उसको उछालना नहीं है, ठीक है? So what you will simply do, you will not make any type of angles, ठीक है? आप उसको just ऐसे roll करोगे, आप उसके ऊपर just एक force apply करोगे and it will not go in air but be in the ground, ठीक है? So roll, it will not go in air, ठीक है? In air. But when you used to kick a football or anything ball, it goes to air in the same way that if this person has kicked this ball and it goes to some, and then at this place this ball has again came to the ground. Okay? Here you can see that this person has kicked this ball and after some time it again comes to the ground level. Okay? So can you say that it has been gone with some angle? You can say some theta. Okay? So yes, it is going with some angle. He has kicked that ball, and when he is kicking, he is making some, you can say, angle, and that angle is theta. Okay? So what you have to do now, understand if it is going to the air and if it is being in the ground. Okay? I am making another line so that you can understand. Okay? So this line is same as ground. Okay? This line is same as the ground. So can you remember the concept of the graph in motion as straight line? If you can't, kindly go and see. You can see if you have you can see your formula sheets or anything else. Here, can you remember the x-axis is known as cos theta, and it is given with the value sin theta. And if I am saying that if I am saying that this ball has gone to, you can say, gone with some angle, with some theta, and its vector is u vector. What I am saying? U vector. So what will be its ground level? या फिर x axis क्या होगा? It will become u cos theta, and this y axis will become u sin theta. So what can I say? That x axis can be written as u cos theta, and y axis can be written as u sin theta. Theta is the angle and sin cos trigonometric ratios, and u is the vector here. Okay? So this was the two topics. Okay? It is very important, and we are also going to make, you can say, derive some formula on the basis of these values. So it is very important. One more information, that this motion in a plane is also known as projectile motion. Projectile motion means if in any place in the place of motion in motion in a plane, and if there is a written, you can also replace the motion in a plane with the word that is projectile motion. Let us understand what is meant by projectile motion, and I am going to give the definition of the projectile motion. Then what we are going to do? Then we are going to, you can say, find some formula, find some algebraic expression, which is very important to find out some other values. So let's come to the next topic to understand the projectile motion. Let's come to the next topic. Let's understand what is meant by projectile motion here. So if I will write here, first of all I am going to write the definition, then we are going to understand that definition with the help of this example. So projectile motion is that if a particle is projected, here you can see here you can find a word that is projectile and projected. Okay, I will make you understand, don't worry. So if a particle is projected with angle theta at horizontal axis, I will not write here horizontal axis, I am just writing here horizontal level. If a particle is projected with angle theta at horizontal level, that motion will be known as projectile motion. Okay, I am not writing here projectile motion. So what is projectile motion? Projectile motion, the motion in which a particle is projected with angle theta at horizontal level, but if a particle is projected with angle theta at horizontal level, then that motion will be simply known as the projectile motion. One more thing, that projectile motion is also known as motion in a plane. So first of all, what you have to observe here. Now you have to assume this football as a particle. Here you can see that according to the definition, it is also same. Here you can see that this person is kicking, projecting this particle with some angle, that is theta. Okay? And this ball you can see already is in the horizontal level, that is known as ground here. And that's why this motion which is happening here also is known as projectile motion. Now there can be three cases that can be made from this situation. Okay? Let's talk about that cases. So case number 1, case number 2, and last but not the least, case number 3. In the case number 1, it will be asked that what will be the horizontal motion here. Means you can see that this ball has came here to here, means it goes from position A to position B. So it will ask that what is the horizontal position from A to B. Okay? So I can write here horizontal position. Okay? With respect to time, here time will be given. We are not saying that without time. Here time is given, and very soon we are also going to understand that topics also. What can be the case number 2? The case number 2 can be like this, that what will be the highest, here you can say, first of all I will erase all these things. What can be, second question is it can be like vertical position. Vertical position means it can be asked that what is the maximum height of this ball. Okay? So then this will be referred as vertical position. Now it is not vertical position, it is motion. And the third case that can be made from it, that is what is the net displacement here. Okay? You can say what is the net position here, like this. If it is asking that at this time in which the horizontal you can say horizontal motion is this, and this is means the height will be the vertical motion, means net. It is in the third case will be our mixture, that what is the net motion here, net motion here. Here you can see see that this maximum height of the ball can be written as y, and the horizontal level can be written as x axis. Okay. So now we are going to, in our next topic, we are going to talk about the horizontal motion, vertical motion, and net motion, and we are going to derive some expression which can be used to find the horizontal motion, vertical motion, net motion. Because the question will become like this, that the angle is 37 degree and the initial velocity was 10 meter per second or 20 meter per second, and it is asking that in 10 second what is the maximum height, what is the horizontal motion here, and what will be our net motion here. It can also be asked, and on the basis of 3 cases we are going to derive 3 formulas from here, and after deriving 3 formulas from here we are also going to solve 2 questions on this topic also, and this will be our today's topic. Let's come to our next topic to understand that is. Okay, so let's understand the horizontal motion here first. Horizontal motion. As I have already told you that here time will be given. So if you want to take out the displacement, if you want to take out the motion, if you want to take out the distance or the displacement and the time is given, actually it will be displacement here, because I have already told you and I have already explained you in the equations of motion of accelerated motion. So what will be the equation that I can write here with respect to time, and I have to find that displacement here. It will be x is equal to ut plus half of at square. Can I write like this here? Yes, simply. First of all, one more thing, that here a will be g. G means acceleration due to gravity. Now here, because initial velocity is of x-axis we are finding out from the x, so that's why I'm writing here, and half here gt square. One more thing, that we are finding out the horizontal motion. Can you let me know that what will be the value of acceleration due to gravity here? Simply it will be 0, because it is falling from upward position to the downward position, not from sideways. Okay? It is not going to this side. It means that simply the gravity does not exert it on the ground. Okay? It is asking for ground. Our acceleration due to gravity always exert from the upward position to the downward position. So simply the g will be 0, and we will get x is equal to u x t. Let me know what, as I have already told you, u cos theta. So x is equal to u cos theta and t. It will be our first. And x is representing here motion of horizontal. Here you can see horizontal line motion, and x is here motion. X-axis simply. So if in any question the time is given, the theta is given, also the angle is given with the initial velocity, means agar aapko diya hai, it is given time and also initial velocity. So you can find out the horizontal motion in the x-axis with the help of this formula, that is u cos theta into time. U cos theta into time, it is very important. It is our resultant formula here. Now, our second will be vertical motion. Okay? Vertical motion. So, I will write here I will write here y, because I am finding out the maximum height. Then you can say vertical motion of the ball, or you can say or the particle. So, we are finding out from the y-axis, and that's why I am writing here y. So, ut plus half of at square. In the place of u and a, we can write like this, that uy and ay. Sorry, I will write here y is equal to uyt plus half of half of a y t square. ठीक है. Now here you can see that a y, as we know that here the gravity is exerting, so a is equal to minus g because it is exerting downward, so minus g, and it will be equal to 10 meter per second square. 10 meter per second square, but now there is no use of this 10 meter per second square, only minus g. I am going to put this minus g value here. So y is equal to u by t plus half of minus g t square. So when you will put the value u by t minus half gt square. So when we will put the value of u sin theta here, so we will get y is equal to u sin theta minus half of gt square. First of all, let me see, can you see or not? Yes. And this will be our second formula. If the horizontal motion is asking, and the question is asking just the displacement, and all these things are given, so you can find out the horizontal position. And if it is asking like what is the maximum height here, what is the vertical position here, what is the vertical motion here, simply this formula will be applied, that is y is equal to u sin theta minus half of gt square. This is our second formula, and both of these are very important. Let's come to our last topic, that is our net displacement. But I'm thinking that I should write it all here. Can I write here? Let me see. Yes, of course. So third is our net displacement. अब इसमें आपको थोड़ी समझने की जरूरत है, लेकिन बहुत इंपॉर्टेंट है, वेरी इजी. ठीक है, इसको थीटा तो आपको थीटा याद होगा ही हो. इफ इट इज आस्किंग दैट फ्रॉम हियर टू हियर, ठीक है, यहाँ से यहाँ तक you have to find out the net displacement. What is the displacement here? Here it is not asking specifically from the x-axis. It is not asking for specifically y-axis. It is asking for the mixture of x-axis and y-axis. ठीक है? So in this place, first can you see here this is y-axis, and can you see here that this is x-axis? Now what will be the displacement here? Displacement is the shortest position, so shortest distance from the initial position to the final position. So here what will be the, this is the displacement here, and you can apply the formula here now. Hypotenuse is equal to squares, the addition of squares of both the other sides. Like हम क्या लिख सकते हैं कि our net displacement will be equal to under root of x square plus y square. And if you want to know the real formula, what you have to do, you have to put the value of x here and y value here. So it will become very you can say very long formula, and it will look also lengthy, and due to this it can be difficult also. So what you have to do, you have to just learn it. And this was our third important formula. You can learn it very easily because I know you all if you have already understood it, you can understand everything here. But if you haven't understood this question, this example, simply you will not able to understand the vertical position, so vertical motion, horizontal position, also the net displacement. So this was all our today's theory. Okay. Now let's come to the next topic to solve some formula. Solve some question. अब क्वेश्चन में क्या करने वाले हैं, all these three things will be given, and it will ask that in this time find out the horizontal position. In this time, in 10 seconds, let's assume it will ask for vertical position, vertical motion here. ठीक है? So let's come to our next topic to solve one question on it. Okay, so our question is like this. It is very simple question, and as you were feeling that the question will be very hard like this, but the question is very easy. हो सकता है आप इसको easy मान रहे हो सकता है, ठीक है. Now here it is given that the theta is here, angle is 60 degree, initial velocity is 10 meter per second. It is asking that horizontal distance in 10 second. दूसरा पूछ रहा है vertical distance in 10 second. Third is what is it asking? That displacement in 10 second. So first of all, let's take out our horizontal position. Horizontal distance with the respect to time दिया है, तो what was the formula? It was simply x is equal to u cos theta. It is simply is equal to u cos theta is equal to t. Now here क्या होगा हमारा? थीटा 10 cos 60 है हमारा, तो cos 60 कितना आता है हमारा 1/2 and time is here 10 second. मतलब as you all know कि cos 60 degree is equal to 1/2 sin 60 degree is equal to under root 3/2. ठीक है, cos 60 degree is equal to under root 3/2 cos 60 is equal to 1/2, sin 60 is equal to under root 3/2. Actually I got confused with some words, you can say. Just 2 5 to 10, here 50 meter will be our answer. Simply can you guess, is there any problem? No, nothing. So here 50 meter will be our answer. It is our horizontal distance in 10 seconds. Very easy. Next, what is our next formula? सबसे पहले what is our next formula? U sin theta t minus half gt square. So u sin theta, u means 10, sin theta under root 3/2, and then it again became 10 minus half. What is the g here? Acceleration due to gravity. It will be simply 10. 9.8 होता है, लेकिन यहाँ पे simply what you have to do, whether it will be given in your question or if it is not given in your question, you can put the value, that is t. So into 10 and t is 100. T is not 100, t is 10 second, but t square is 10 times 100 here. So 2 5 जा 10, ठीक है, then 2 5 जा 10. Here what will be our answer? So 50 into 10, 50, 5 into 10 into 50 in minus 500. ठीक है. In problem is here that our answer is like this. Our answer is 50 under root 3. 50 under root 3 minus 500. So we can take out the common. So it will become simply 50 bracket under root 3 minus 10. It will be our answer. Second question. And third will be our a little bit, मतलब इसका formula क्या होता है? x square plus y square. So we can put the value. So x square. Okay. So what is the net displacement here? What it is given? Displacement in 10 seconds. Displacement in 10 seconds. So for finding a displacement, we can simply find out the displacement with the help of our previous concept. So I think now what you have to do, you have to just put the value of 50 and 50 under root 3 minus 10. You have to just put the value and find out the answer. ठीक है, this will be our displacement, and as it is very easy, it is all for all of you, it is like homework. ठीक है. So if you have any doubt related to any question like this, any problems in this whole video, any doubts or any you can say any improvement that you can see in this video, kindly comment down. It will simply motivate me, and if you like this video, kindly like, and thanks for watching.